Okay, coming to SI engine, that means spark ignition engine or gasoline or petrol engine. Okay, we have already gone through this four-stroke SI engine, two-stroke SI engine. Okay, and how why we call them as a gasoline engine or petrol engine? Why? Because in this type of engines, we are going to use petrol as a fuel. Okay, so that's why we are going to call it as gasoline engine or petrol engine. Okay, this is how we already know how it is going to work on. Okay, we already gone through working principles of all these two-stroke, whether it may be a two-stroke or four-stroke engine. Here, I'm going to show about the four-stroke SI engine. See here the process, what is process 0 to 1 or event 0 to 1 suction stroke, and what is second event compression, that is from 1 to 2, and what is third event 2 to 3 at a constant pressure there, sorry, at constant volume there will be a heat addition. And what is the next event or fourth event? Expansion. Okay, during this event what is going to happen, the whatever the combustion products are there, those will try to move the piston downwards, and there will be some power is going to be produced here. So we can call that as work output. Okay, work output. And what is 4 to 1 or 4 to 5? This is nothing but exhaust. Okay, during this what is going to happen at constant volume? That means when the piston is at bottom dead center within the cylinder, all the gases are going to leave to the atmosphere. So this is work input. Process 1 to 2 is work input. Since we are going to compress this, pressure and temperature are going to increase. And what happens to the volume? Here volume is going to reduce. So that's why pressure and temperature are going to increase. Okay, and what is process 2 to 3 or combustion? What is that event? Combustion event at a constant volume, since it is SI engine. Okay, and what is 3 to 4? Expansion stroke. And here we are going to, here we are, this is the work input, and this is heat addition, and this is work output, and 4 to 1 is heat release. Okay, 4 to 5 is heat release. Okay, this is work input, heat input, this is work output, this is heat release. 4 to 5 or 4 to 1 is heat release. Okay, those are the process and which is going to be happen here within this ideal PV diagram of a four-stroke engine. Okay, we have already gone through this. This is basic cycle fuel, that means which fuel we are going to use, and how much pressure is there. Okay, that means here for a SI engine, the self ignition temperature is high, that is around 280 degrees, and for diesel is only 210 degrees. Okay, so we can't ignite the fuel, that means the gasoline or petrol uh, easily. Okay, with the high since that also we are going to use the low compression ratio, so we can't self ignite the fuel. Okay, so that's why we are going to use the spark plug here. Okay, and how we are going to introduce the fuel? A gaseous mixture of air fuel is introduced. Okay, during the suction stroke. Okay, and here we use carburetor and ignition system. Okay, here ignition system means nothing but spark plug. Okay, and how we control load? Okay, throttle control is the quantity of air fuel mixture introduced. That means depending upon the throttle valve will be there, throttle valve will be there. Depending upon that throttle valve, we are going to control the load. Okay, and coming to the ignition, we are going to use the spark plug here. And the compression ratio, we will use a compression ratio of 6 to 10. And speed, okay, due to heavy sorry, here when compared to CI engine, here we are going to have lightweight. In case of SI engines, we are going to have lightweight, and also we are going to use homogeneous combustion. Homogeneous means before coming to the combustion chamber only, we are going to use air fuel mixture. Okay, so here homogeneous within the cylinder, that means before coming to the combustion chamber only, we are going to mix air and fuel. That's why we are going to call it as homogeneous. Okay, and so that's why they are high speed engines. And coming to thermal efficiency, as the low compression ratio is low, we are going to have maximum thermal efficiency when compared to the CA engine. Okay, and here we are going to have lightweight due to lower peak pressures. Okay, coming to CA engine, here this CA engine which is going to work on diesel engine, we already know 0 to 1 is suction and 1 to 2 is combustion, and here at constant pressure we are going to have combustion, and 3 to 4 is expansion. That means piston is going to travel from top dead center to bottom dead center. During this piston, gases which are there are going to push the piston downwards to bottom dead center, and 4 to 1 or 4 to 5 is exhaust. That means all the gases are going to leave from the cylinder to the atmosphere. Okay, so this is the work input, and this is heat supplied, and this is work output, and 4 to 5 is the heat rejected. Okay, here we are going to supply heat, here it is going to reject, and this is work input due to compression, and this is work output due to power stroke. Okay, power is as power is going to increase, pressure and temperature are going to relieve. Okay, so there will be reduction in pressure and temperature, and because of increase in volume. Okay, so these are the features of CI engine. Basic cycle is diesel cycle, and coming to fuel, we are going to use diesel as it is a non-volatile fuel, and also we need to attain self-ignition temperatures. So to have self-ignition temperature, we need to have more compression ratio. Okay, and how we are going to introduce fuel here? First of all, the air will be there, and after combustion is going to happen when at the end of compression stroke. Okay, when we inject the fuel at the end of compression stroke, then we are going to have combustion, and here we need a fuel pump and injector. In case of SA engine, we used spark plug, but in case of CI engine, we need to have fuel pump and injector. Okay, and the quantity of fuel is going to regulate the control. That means load control is depending upon the quantity of fuel. Previously, we have throttle valve in SA engines. In CI engines, we have quantity of fuel is going to regulate the speed of the engine. Okay, and here how ignition is going to happen? Because of self-ignition temperature. The fuel which we use have to ignite its own because of it should reach its self-ignition temperature. For that, we need to improve the compression ratio. To reach its self-ignition temperature, we need to maintain the compression ratios from 16 to 20. Okay, and due to heavy weight and heterogeneous combustion, here why we are going to have heterogeneous combustion? Homogeneous means before the cylinder we have to add air and fuel, but here in this heterogeneous combustion means before that means first of all we are going to take air in a suction stroke, and at the end of compression stroke, okay, we are going to add fuel. That means in cylinder, within the cylinder, we are going to have two types, both air and fuel. So that's why we are going to call it as heterogeneous combustion. Homogeneous combustion means before coming to a cylinder, they are going to mix. Heterogeneous means after coming into the cylinder, those two are going to mix. Air and fuel are going to mix. So that's why we are going to have low speeds here. Okay, and because of higher compression ratio, the thermal efficiency is going to be high, and here we are going to, as the compression ratio is high, the weight and peak pressures are going to be high here. Okay, so that's all for today. If you have any doubts, please raise your hand, and if you don't have any doubts, I will end the session. Sripad.